Okay, this is another expansion problem, except this isn't length expansion, this is volume expansion. So the same thing, just like a solid, if I take a solid and I heat it up, it's going to expand because the molecules move more and more and more, right? Same thing's going to happen with a liquid. If I take a liquid, like here, the molecules are all moving around. They have some temperature, right? And if I increase the temperature, that's going to make those molecules move around faster. And if they move around faster, they're taking up more space, they're bumping into each other, they're pushing each other out of the way, right? So it's going to make the volume of the liquid expand. So the volume expansion equation is exactly the same as the length one. All I'm doing is swapping out length for volume. So my change in volume, delta V, is going to equal my coefficient times my initial volume times my change in temperature. That's the exact same equation as the length one, except before length one said delta L and L naught. Same thing, right? And what else do we know? Okay, so this is a sphere. This sphere volume is going to expand into a cylinder. So I basically have to know the volume of a sphere and the volume of a cylinder. So we can also write down the volume of a sphere is equal to 4/3 pi r cubed, right? That's the volume of a sphere. And the volume of a cylinder is basically a circle that gets, right? It's a circle that gets expanded upwards. So it's pi r squared, which is a circle, times the height. And look at that. So I'm trying to solve for height. There's height. So I know I'm going to have to basically find the new volume that expands into the cylinder, add it up, and solve for height, right? So the question is, how do we go about and do that? Like, you can look at it, but how do we accomplish that? So first, let's start by doing this. So I can say change in volume is my coefficient. Do I have the coefficient? There it is right there. My coefficient of expansion. So I know that. So that's alpha times my initial volume. I don't know that, so I'm going to have to solve it. So that's going to be 4/3 pi. I have a diameter, right? So I'm going to take my diameter. Let me make that a bracket. Diameter divided by 2, right? I have to cut my diameter in half to get radius. Squared, 4/3, I'm sorry, cubed, because it's cubed. It's a sphere. 4/3 pi r cubed. There's the volume of a sphere. Right? That's my volume, times my change in temperature. So what's my change in temperature? It started, temperature change up there, it just gives it to me, right? So there's my delta T. It's that number right there. There's my alpha. So times delta T. And then I can solve for change in volume, right? And that'll give me delta V. Okay, so now that I know delta V, that's all in here, right? So this part here, that will be your delta V, because the original was all in the sphere. So whatever you get here is equal to the volume that goes up, right? So all you have to do is say, my change in volume is equal to the volume of a cylinder. And you can set the volume of a cylinder, right? We know volume of a cylinder is pi r squared h. So I can say delta V equals pi r squared h, and then you're trying to solve for h. And so again, it gives you the diameter of the tube, right? So see how it has diameter? You need to cut that diameter in half. It needs to be in meters, right? Same thing with this. It needs to be in meters. That's centimeters. You can turn that to meters. You should be in that habit by now. Well, actually, no, you don't, because it's in centimeters. You're going to turn it back. So, yeah, so you don't need to. Oh, joke's on me. But anyway, so if you want to solve for h, you can just move that over and solve. You have everything you need now that you solve for change in volume.